From Here to the Stars, a video series created by the Tennessee Valley Interstellar Workshop. The TVIW is a non-profit organization dedicated to thoroughly exploring the science and engineering that can eventually open up the reality of interstellar travel. I am your host, Stephen Euin Cobb. Our guest today is Dr. Gregory L. Matloff. Dr. Matloff is Emeritus Associate and Adjunct Associate Professor of Physics at New York City College of Technology. He has consulted for the NASA Marshall Space Flight Center, is a Fellow of the British Interplanetary Society, is a Hayden Associate at the American Museum of Natural History, and is a corresponding member of the International Academy of Astronautics. But first, a brief perspective on Dr. Matloff's work by one of his co-authors. Here is Les Johnson, Senior Technical Assistant for the Advanced Concepts Office at the NASA George C. Marshall Space Flight Center in Huntsville, Alabama.
If you look back on the history of this field, in terms of when all the groundbreaking ideas that are now commonplace in the interstellar field first came about and were first published back in the really 1960s and 70s, there are two names that come up more often than just about any other name in the journals coming up with the innovative ideas for how we might actually get to the stars. One is the late Dr. Robert Forward, who is an awesome inventor, scientist, and science fiction writer. And the other is Dr. Greg Matloff. And if you go back and look in the red letter editions of the Journal of the British Interplanetary Society and the Acta Astronautica and other science journals of the time, where people were bold enough to put ideas out there about how we might actually go to the stars and put forth physically plausible solutions for the first time ever. A large fraction of that work was done by those two people. And Greg is half of that duo. It's just incredible if you do a lit search.
Okay. You know his work. You're familiar with a lot of the books that he's written, even if you weren't involved in them all. What is it you'd most like to hear him talking about?
The Starflight Handbook.
The Starflight Handbook?
Oh, it's an awesome book. It's in like third or fourth printing. It is not a monograph. It does have math equations in it. It is a text, not a textbook. It is a book about all the different issues with deep space flight, written at a level that a student in college who's finished second semester of physics could go in and actually solve some of the equations to figure out their own starship design. It's a wonderful book.
Okay.
And it's in like its third or fourth hardcover printing. It's been out for like 2 decades. It's Greg's most successful book by far. And to me, when I think of Greg's achievements in academic books, it's the one. And it's not one I did with him. It was done before I met him. It's a great book. So that would be one. And he did a more detailed version, which is an incredibly detailed technical monograph for a graduate student level of physics called Deep Space Probes. And that is, if I were interested in the interstellar field and just getting acquainted with it, actually, this is what I did. That was one of my first purchases. It was great. So, it is the starting point that I would recommend to anybody who wants to understand this field. It is one of the first books I would buy. Absolutely.
And now, Dr. Gregory L. Matloff.
My familiarity with having interviewed you, years ago, is mostly concerning propulsions with light sails. Are you continuing in that, and does that relate to interstellar exploration?
Yes, I've been doing a lot of work with light sails. One thing that I've done is I've been able to find a certain amount of evidence about how graphene could operate as a light sail. Graphene is a form of carbon that's one molecule thick. It's very strong. It is very impermeable. If it's sort of a balloon, it won't leak gas out of it. It's very impermeable, and it is surprisingly absorptive. And if you dope it with the appropriate material, the absorption can go up to 40 or 50%. If this can be manufactured in quantity and in space, and it continues to hold up, it means we can certainly get very large payloads, probably interstellar arcs to the nearest star within 1,000 years flight time. A robotic probe, a thin film probe using the sun alone, could get up to a speed faster than 1% the speed of light, But the problem is the accelerations that are very, very high and they would squash human beings and probably most other forms of life we could imagine. So I think we're still stuck with the 1,000-year arc, but it's a lot easier to do with graphene and with more dense materials. That's one thing I've been doing. I have 3 papers in the Journal of the British Interplanetary Society about that. In this particular conference, I've been looking at it in another way. My feeling is that we've already flown 3 solar sails in space. NASA's flown 1 in near-Earth orbit. The Planetary Society has also flown 1 in near-Earth orbit. And the Japanese have flown 1 between Earth and Venus. But these are all basically nano sails. They're cubes. They've been deployed from CubeSats. The size of these things are maybe 20, 30, maybe 40 feet across, something like that. I forget the exact size of it. We want to be able to demonstrate that we can use things at least close to 1 kilometer across. So I started to play with an idea for the Tennessee Valley Interstellar Workshop, which is about to start. That's my plenary paper is about this. And I said, okay, let me look into the possibility of not really going to Mars, but going to a nearby asteroid. And I don't want to do it with the Space Launch System. The NASA Space Launch System is very expensive. It can probably only be launched once every 1 or 2 years. And it's going to be very vulnerable to whatever politicians want to do with it, because it's something that was really pushed forward by people in the Senate, and some people have said it's more of a jobs program than a space program. So I wanted to look at a backup to see how well we could do with a modest exploration beyond the moon. So I looked instead at Elon Musk's Falcon Heavy. And Falcon Heavy basically will take 3 Falcon 9s, rope them together, and have another same second stage. It'll be able to put more than 100,000 pounds into low Earth orbit and approximately 30,000 pounds of payload to the vicinity of Mars. So I started to investigate what could we do with near-Earth orbits, with near-Earth asteroids, and this would give us an experience with getting astronauts beyond low Earth orbit. It would give us experience with working partially with scalable environmental control systems, and maybe also we could use the solar sail. So I went through this analysis and demonstrated that it might just be possible. What you have to do is, I wanted to constrain the flight time to 1 year, because beyond 1 year, you start running into significant possibility of cosmic ray damage to the crew unless you have more shielding. And you would have the self-shielding in this craft would be marginal for that. So you would also have to send older astronauts. And I found a wonderful study on space radiation by Suzanne McKenna-Loyler and her colleagues in Acta Astronautica. And I was able to demonstrate that, yes, if you could keep your crew in space through a year, and it's a small crew, the self-shielding with a Dragon and a inflatable module as your basic structures on this craft would be enough. So I said, okay, you can launch it to the vicinity of the near-Earth asteroid, certainly. There's enough life support. You have enough mass for the life support. And I used, I forget his first name, Rapp's analysis of life support from his book on flying to Mars. And I put all this together, and I said, well, they still have to rendezvous with this near-Earth object, and then they have to fly back. So for that application, they would have a kilometer-wide solar sail, about a kilometer wide, and it would work with basically the conventional sail designs, maybe a couple of grams per square meter, something like that. I forget the exact amount, but it's in the paper. And it turns out that for a small crew, the Falcon Heavy with a Dragon and a inflatable beam module, it's called, one of Bigelow's modules, will be testing this on the space station in the near future. It just may be marginally possible to do such a mission. It would be very interesting because they only have one airlock, and when they're exploring the near Earth object, they would probably have to disconnect the beam and the Dragon, and all of the 2 or 3 astronauts on board would have to don spacesuits, of course. And they would have to be well tethered. Everything would have to be tethered together. But it certainly could be done. It's not I don't think it's an impossibility, and it would give us experience with interplanetary solar sailing. It would get us beyond the moon, and it would be dependent upon a dysfunctional Congress.
Okay. Before I let you go, are there any last comments you'd like to squeeze in? Maybe a recent book you've put out?
Okay, well, the recent book that I put out, Starlight, Starbright, that's the most recent one. I do have 2 books with Les Johnson and C. Bangs doing the art, which are a bit older. Harvesting Space for the Earth's Benefit is one, which was the 2nd edition of Paradise Regained. And before that, we had Living Off the Land in Space. So we have a couple of books out. And C's book, the artist's book, which accompanies Starlight, Starbright, is simply called Starbright. And that's basically, it's short, and that's the one that's been collected by the Museum of Modern Art in Manhattan.
Excellent, excellent. Thank you, Doctor. I sure appreciate you taking the time for the interview.
Well, you're welcome, Steve. I'm glad I was able to get you.
That was Dr. Gregory L. Matloff. I have been your host, Stephen Euin Cobb. If you enjoyed this video, please click the like button, and you can subscribe to our channel for more such videos. On behalf of all of us here at the Tennessee Valley Interstellar Workshop, I thank you.